Hi everyone, it's Perry from Math Together Canada, and we've made it to the final stretch of the 2024 AMC 10A with Prince Zhang. In this last video, Prince will be tackling questions 21 to 25, the most difficult and rewarding problems on the contest. These questions require creative thinking and sharp problem solving, and Prince is here to walk us through each one step by step.
Alright, let's proceed with problem 21. The numbers in order of each row and the numbers in order of each column of a 5x5 array of integers form an arithmetic progression of length 5. The numbers in positions 5, 5, 2, 4, 4, 3, and 3, 1 are 0, 48, 16, and 12 respectively. What number is in position 1, 2? So first let's set some variables. We'll have this column be A, 2A, 3A and 4A, and we'll have this row be B, 2B, 3B, and 4B. Now we have 2B and 16 here, so using the arithmetic progression, we find that this term will be 32 minus 2B. This one will be 48 minus 4B. This will be 64 minus 6B. Now, we can look at these three right here. Since they're in arithmetic progression, we can use the fact that this one and this one sum to make double of this. So let's write that mathematically. And now let's cancel out the terms and do some rearranging to get this. And now let's look at this row. Since these are equally spaced, since they both have one term between them, we can also use this property. So now we have these two equations. Let's number them 1 and 2. So now let's do equation 1 plus 2 times equation 2. We get 3a minus 4b plus 2a plus 4b is equal to 48 plus 2 times 26. So on the left side we have 5a, and on the right we have 48 plus 52, which is 100. So a equals 20. Now we can plug this back in. Let's plug it to equation 2 because it looks simpler. But really we could also plug it into equation 1 if we wanted. And we get b equals 3. Now here we can solve for the top row. So in the top row we have blank. Now 64 minus 6b is equal to 64 minus 18, which is 46. So we have question mark, 46, blank, and 4a, which is 80. Now we can average these two terms to find the fourth term. So let's do that. And we should get 63. So now this term is 63. And so let's set this term equal to x. We have, with the arithmetic progression, we have x plus 63 equals 2 times 46. Now if we solve this, we find x equals 29. And so our answer is C. Now problem 22. Let K be the kite formed by joining two right triangles with legs 1 and root 3 along a common hypotenuse. 8 copies of K are used to form the polygon shown below. What is the area of triangle ABC? So there are many ways to solve this, but we'll just use the formula area equals half of BH. And so let's start by labeling some angles. Here we can see this is, and sides, this is square root of 3, this is 60 degrees, this is 1. And so first let's solve for the height. We know that this is a right angle. So the height from C to AB, this length, is equal to this length, since these lines are parallel. Now this length here is root 3, and we can find this length by using the fact that this angle is 60 degrees. So this line right here has a length of root 3 over 2. So our height is square root of 3 plus root 3 over 2 equals 3 root 3 over 2. Now for our base, we see that each of these 4 segments are equal. And in this segment, right here, because it's across from this 60-degree angle, we know it's root 3 times this segment. So it's root 3 times square root of 3 over 2. This is equal to 4 times 3 over 2, which is equal to 6. So now we can solve for area, and we can plug these back in. We get area equals half of 6 times 3 root 3 over 2, and we get 9 root 3 over 2. And so our answer is B. Alright, now problem 23. Integers a, b, and c satisfy ab plus c equals 100, bc plus a equals 87, and ca plus b equals 60. What is ab plus bc plus ca? So first let's label our equations. We'll make this equation 1, 2, and 3. So now if we subtract equation 2 from equation 1, we get ab plus c minus bc minus a equals 13. Now we can factor this into a minus c, b minus 1 equals 13. So now we get b minus 1 equals plus minus 1 or plus minus 13. So we get b equals 0 to 14 or negative 12. So now let's do some casework. Case 1, b equals 0. We plug this in, we find a equals 87 and c equals 100. Pretty obviously though, the AC does not equal 60 as shown by the third equation, so there's no solution. Case 2, b equals 2. Here, 2c plus a equals 87, and 2a plus c equals 100. If we make this equation into 4a plus 2c equals 200, and then subtract this equation from this one, let's label it star 2 star, then we get 3a equals 113. 113 is not divisible by 3, so there's no solution here. Case 3. B equals 14. 14c plus a equals 87, and 14a plus c equals 100. Now let's label this triangle, why not? And then we can make the second equation into 196a plus 14c equals 1400. So now we get 195a equals 1313. There's obviously no factor of 5 on the right hand side, so there's no solutions. And finally, case 4. B equals negative 12. Here we have negative 12c plus a equals 87, and negative 12a plus c equals 100. If we multiply the second equation by 12, we get negative 144a plus 12c equals 1200. Here, if we add them together, we get negative 143a equals 1287. And so a equals negative 9. If we plug this back in here, we get negative 12, negative 9 plus c equals 100. So c is negative 8. So now we have our solution. A comma b comma c equals negative 9, negative 12, negative 8. Now we just need to calculate. AB plus BC plus CA is equal to negative 9, negative 12 plus negative 12, negative 8 plus negative 8, negative 9. Equaling 108 plus 96 plus 72 equaling 276. So our answer is D. Now problem 24. A bee is moving in a three-dimensional space. A fair six-sided die with faces labeled A plus, A minus, B plus, B minus, C plus, and C minus is rolled. Suppose the bee occupies the point A, B, C. If the die shows A plus, then the bee moves to the point A plus 1, B, C. And if the die shows A minus, then the bee moves to the point A minus 1, B, C. Analogous moves are made with the other four outcomes. Suppose the bee starts at the point 0, 0, 0, and the die is rolled 4 times. What is the probability that the bee traverses 4 distinct edges of some unit cube? So we can start by drawing the axes. And the bee starts here. So without loss of generality, let's say the bee moves here and then here, since any 2 moves will occupy one 2D plane. The first move has a 100% probability rate, while the second one, the bee has to move perpendicular to its first move, since if it goes forward from here or back, it won't be part of a die, so it will be 4 over 6. Now here it splits into 2 cases. Case 1. The bee extends into the 3rd dimension. Here it has 2 choices. It can either go this way or this way, which would extend into the other dimension. So here, and then afterwards for the final move, without loss of generality, let's say it went here, then it has two options. It can either go this way or this way. So for case 1, it's a 1/9 probability. Case 2, the B stays in the same plane. And there's only one option to do that, so it's 1/6. Now from here, it has three different possibilities. It can go right, it can go left, or it can go down. All three of these moves would still allow it to stay on some unicube. So we'll multiply by 3/6 to get 1/12. So now we combine the cases here, 1/9 plus 1/12, and now we just evaluate. We get 7/54, so the final answer is B. Now finally, problem 25. The figure below shows a dotted grid 8 cells wide and 3 cells tall, consisting of 1 inch by 1 inch squares. Carl places 1 inch toothpicks along some of the sides of the squares to create a closed loop that does not intersect itself. The numbers in the cells indicate the number of sides of that square that are to be covered by toothpicks, and any number of toothpicks are allowed if no number is written. In how many ways can Carl place the toothpicks? So firstly, we can observe that if a toothpick is placed in between two cells, for example here, then it has to extend all the way to the end, because it cannot go left or right, or else that would have two toothpicks on these cells. And our second observation is, if it extends end to end, then that means no toothpick can be placed here, 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 or here. Because if it were, there would be no way to form a closed loop without ignoring one of these sections to the left or to the right, which would mean that this cell isn't satisfied. So now with these observations, we can make some cases. Case 1, the toothpicks are on the ends. We have case 2, where one of the toothpicks is on the end. Case 3, the other symmetric way of case 2, and finally case 4, where none of them are on the ends. So for case 1, we can draw out, let's just draw here. For case 1, it has to extend all the way. And the only way to keep connecting it is to also extend here. Now we have two choices. We can either have one on the top with the bottom coming in to touch the side of the square, or we can have the opposite way, the one on the top. And of course, if two of them are adjacent, we can just do like this. So now, there are 6 options. And with each option, we have two choices. So there are 2 to the 6 equals 64 ways for case 1. Now for case 2, it's the same principle but slightly different. The toothpicks end here. And so there are only 5 options. So there are 2 to the 5 equals 32 ways. The same for case 3, since case 3 is just case 2 but mirrored. We also have 5 options here. Now case 4, where both of them aren't on the ends. Here we have 4 options, so 2 to the 4 equals 16. Now, importantly, we missed out on 2 cases. The first case is one that doesn't have to go through the middle. We can satisfy all the conditions by doing this. And so this adds another way. And obviously we can also move this to the bottom, which would also add one way. So in total, we have +64 +32 +32 +16, and then +2 more, which gives us 146. So our final answer is C. And that's it for AMC 10A 2024.
That concludes our full AMC 10A walkthrough. Thank you so much to Prince Zhang for sharing his time, strategies, and passion across all 4 videos. We hope this series helped you learn something new and inspired you to keep growing as a problem solver. And if you'd like to record your own math video, whether it's contest solutions or cool concepts, we'd love to feature your work. Reach out to us anytime at contact@mathtogether.ca and be part of the Math Together Canada community.